In example 3, we have h of x, a piecewise function made up of 3 pieces, a quadratic, a line, and a constant. We're going to go ahead and find these values. In other words, when x is -2, 0, and 5, we're going to find the y value so that we use those points in order to sketch our graph. Now, we're going to have 3 points, but we're going to end up needing more, most likely, as we try to build the graph. So let's go ahead and find the y values. When x is -2, notice that -2 is less than 0. That means that -2 is going to fall right here in this interval. So we're going to be using the quadratic to find the y value. So we're going to have -2 squared minus 1. This is equal to 4 minus 1, which is equal to 3. So then that's going to give us the point -2, comma 3. When h is 0, again, 0 is included here. So we're going to be using the quadratic. That means 0 squared minus 1. This is equal to 0 minus 1, -1. So we find the point 0, comma, -1. And when h is equal to 5, when h is 5, we are here in the second piece. So we're going to be using the line to find that y value. So that means 2 times 5 minus 1. That's going to be equal to 10 minus 1. That will give us 9. So now we have the point 5, comma 9. So 3 points that are there available for us to use. Now, since I have a quadratic right here, I would love to know the vertex of that quadratic. Every single time that you have a quadratic, you want to find out what the vertex is equal to. So in order to do that, we're going to use the formula h equals -b over 2a. I want you to notice that b is missing. The x term is missing. That means that b is equal to 0. So that's going to give us -0 over 2 times 1, which is 2, and that's going to be equal to 0. That means that the x value of the vertex happens to be equal to 0. So when x is equal to 0, that's when the quadratic is going to have the vertex at x equals 0. We already computed the y value when x is equal to 0. When x is equal to 0, the y value is -1. This is telling me that this point right here happens to be the vertex of the quadratic. So I'm going to start sketching now. I'm going to plot 0, -1 right here. That's a very important point. And then when x is less or equal to 0, again, repeating myself, that's when I sketch the quadratic. Now I need another point on the left of 0. I want to get more points that are less or equal than 0 so that I can nicely sketch my quadratic. Remember, this point right here is the vertex. I'm also going to leave a solid dot because 0 is being included right here. All right, so let's say that we choose -2. If you notice over here, we already computed the y value when x is -2. So I will definitely take advantage of this point right here. When x is equal to -2, the y value of the quadratic is equal to 3. So -2, that means right here. So already I can start drawing this quadratic like that. If you want to plot more points, you can perfectly go ahead and do that. Now let's go ahead and sketch this line right here. This is going to happen when x is between 0 and 5. To sketch a line, I only need 2 points. So the points that I'm going to use are going to be the transition points. Even though 0 is not included in this interval, I am still going to use it here within the line to determine how far left the line is going to go. Again, 0 is not included, but I'm still going to plug it into the line to see exactly when the line on the left is going to start. So let's go ahead and do that. We're going to have here y equals 2x minus 1. And I am going to take the value of 0 when x is 0. When x is 0, y is going to be equal to 2 times 0 minus 1. That means 0 minus 1, negative 1. So that gives me the point 0, comma, negative 1. So in other words, if you notice, this is exactly this point right here, the vertex of the parabola in the previous interval. This is already a closed dot. So then that dot will stay as a solid dot. So again, right here, that is going to stay there. There's going to be a connection. Now, as a line, I need another point. So I will conveniently use the other transition point, 5. Now, 5 is included in this interval. So when I plot that point here, it's going to appear there as a solid dot. And you can see that we already nicely computed the y value when x is equal to 5. When x is equal to 5, the y value is equal to 9. That means that we're going to go all the way here. This is 5. I'm going to have to extend my axis a little bit further to capture the y value of 9. And then I'm going to go all the way there, right here. And that's going to be a solid dot. So then I'm going to go and join those 2 points right there. And that's what I end up getting. Now for the third piece, x is greater than 5. When x is greater than 5, the y value is always 3. And now 5 is not being included. I still have to begin when at x equals 5, but because 5 is not being included, I am going to show that by placing an open circle. Let me do that in green, something different. So I'm going to have when x is equal to 5, the value should have been 3. But because 5 is not being included, I'm going to leave that as an open circle. And then I am going to draw the line towards the right, all the way like this. So now I have a beautifully completed graph. If I want to state now the domain of this graph, so that domain is going to be equal, let's see, pretty much every x value is being determined here, same thing over here, same thing over here. So that domain consists of all real numbers. So everything from negative infinity towards positive infinity. Now the range, let's look at the range. This graph, this piece goes all the way up. So all of positive infinity is included. But then the lowest y value that I see right here is at negative 1. So all the way at positive infinity, and then the lowest y value, negative 1. That means that the range consists of all y values that are greater or equal to negative 1. In interval notation, that will be from negative 1, including negative 1, all the way to positive infinity.